problem is from the fluid power textbook, Anthony Esposito, the fluid power with application. This is the problem number 30 from chapter 6, 7th edition, cylinder chapter. In this problem, there is a cylinder here, and that is applying 1,000 pounds. And then that is translated to move this load right here at point C. So the question is asking how much is this load you can move by this application. And this is fixed right here. Or you can say pivoted. So first thing, we need to find out the force on each of these arms translated by this 1,000 pounds. So under this condition, the easiest way to find forces, whenever you have all the angles known, so we know this angle 120 degree, and then also this angle is 120 degree because this one is 120, so that makes 360. So when you have these all different angles available, the easiest way to find forces, if one is known, is the applying the sine law. Apply the sine law, which is the force in a particular arm is the divided by the sine of that opposite angle are proportional. So if the B arm force is sine of V, and then C arm force, and then sine of C. So they are proportional. So if you apply that, we can write down that if VC divided by the sine 120, in this case, all of them are 120 degree, and then F BD, which is again divided by 120, they're all 120 degree, makes your job really easy. 1,000 pounds divided by 120, sine 120. So we can say that BC, and if we just equate this two, we can see that BC is equal to BD, and then that is equal to, so if we just solve for, let's say, BC, then we can write 1,000 divided by sine 120, then times, there was a sine 120 here, then FBC would be 1,000 pounds. Now this is 1,000 pounds just by chance. Don't think that this always be 1,000 pounds. If this angle changes, then this force will change for sure. So let's so we know now we know this force here, BC arm this way. Now this BD force will be neutralized by this pivot. So the reactions. If I redraw this thing here, so that BD force will be neutralized by this pivot point. However, there is nothing to neutralize this piece. So this FVC, then this cylinder, so there is nothing to neutralize that. So if you divide this into two parts, that's 60 degree. FBC cosine 60 degree, that will be neutralized by the cylinder wall. And then this part would be FBC sine 60 degree. So that will be the load. So that now if you do the summation of Fy, all upward direction positive 0, then FBC, that's a positive sine 60 degree, is equal to the load minus F load, which is downwards, equal to 0. So F load would be FBC. Basically, I'm just making things more complicated here. So it's basically, that's the only component going upward. So 1,000 pounds times sine 60 degree. So that is about 866 pounds. Now, if this angle changes, then their sine law will change and everything else is going to change. Let's just assume this angle becomes, say, 30 degree. Instead of 60 degree, this is 30 degree. So then you got this 1,000 pounds here. Now this angle would be 180 degree minus 30 degree. This angle will also be 180 degree minus 30 degree. I mean, let's say this is 30 as well. So by the sine law, it's going to be, that's B, that's C, and that's D. So by the sine law, FBC by the opposite angle, which is sine 180 minus 30, is equal to, let's say, 1,000 pounds divided by the opposite angle is 60 degrees, sine 60 degree. So sine 180 minus 30 is sine 30. So FBC would be then 1,000 pounds times sine 30 divided by sine 60. So the force would be, let's see, I calculated that force. What is that? 575. Wasn't that? Yeah. So instead of 1,000 pounds, now it's going to be 575. So this 1,000 pound is just by chance, this force on this arm because of this 60 degree angle. If this angle changes, then the force translated to this direction will change and it will be different answer. Now this problem is not a lever problem because lever will have a solid arm and try to create a moment. So that you get the lever advantage. Here, it's not creating any moment. So taking moment is not a good idea. So only of course the dimensions are not given. So thinking about taking moment is another bad idea because you need the dimension to take the moment. So only option you have is to either apply the sine law or resolve the forces. Now when you have to find the forces, then sine law will be easier than to resolving the forces. Resolving forces helps when you have to later on take the moment. If you're not taking the moment, apply sine law to find forces instead of resolving forces.